So one of the things to think about between the difference from when you're really close to the wind and as we move farther away is what the restoring force is for the waves.
The labs were mostly fill in the blank. They were labs where there was one right answer or the students were not able to follow through concepts. One of the problems I found with the labs is that they were standalone. Each lab was individual or separate from the previous lab. If they didn't grasp a concept in one lab, there was no incentive for them to learn it for the next lab.
So last week we did a lab where we did the math, and so we worked through some of the basics of the lab, and then the way the lab's going to work today is we're going to watch 5 experiments.
I'm going to start the wind generation system. And what it does, it's a suction type system down there. Basically, we're drawing air in across the water.
So we have a series of labs that we changed. One was about density, and so they did a little experiment, or they do experiments with a tank and look at different types of density water and what happens when that water sinks in the ocean. The next experiment was one on CO2 and what happens to CO2 when you put it into water and how the density of water affects that CO2. The following lab was looking at how CO2 in water dissolves calcium carbonate, which make up sediments in the ocean. So that's the first wave of lab changes we made. And the next set was actually looking at waves. And for that set of changes, we actually used the wave lab on campus.
So Ingrid was the mastermind for redoing the entire lab course, and I liked her ideas of trying to make it more active, and she asked me specifically, because I'm a physical oceanographer, to work with the people at Marine Hydrodynamics Lab to redo this particular lab and make it more hands-on.
The lab that we're going to be working with today is in the wind wave tank, where you're going to get a chance to take a look at gravity waves formed by a wave maker and also by wind. It started very calm, but I guess as we're starting to get a more uniform type behavior.
Now they're seeing a real scientific facility in operation. That's one thing that's different. And then the other thing that's different is that they're actually, along with that, they're seeing things happen in the lab, and then they're testing that against the formula they learned in class.
This is the beginning of the tank.
So in order to make this lab, I visited the folks at Marine Hydrodynamic Lab many times. The lab that they do previous to this is basically a math practice lab where they practice formula relating the wavelength, frequency, and phase speed of waves. And then this lab, they actually see waves made in a tank. You have them observe all that, and then you give them a hint of what they're supposed to look at in terms of answering the math questions when they get back to this building and look at the pre-recorded tapes.
So we're going to do the video for the last experiment. So this one is the baseline amplitude and higher frequency.
And then they basically see whether the formulae that they learned in the previous lab and in lecture hold up in that lab.
Is that the appropriate formula?
So the idea is that you use these to figure out if it's shallow and deep, and then remember that there's a different set of speed equations for shallow versus deep. So all it's saying is make sure that
I think it's nice for the students to, at least once in a while, have a lab that operates in a real scientific facility to see the messiness.
I see this course is a course where we can teach a large number of students just about the natural world around them. These students are going to go on to become voters and consumers and teachers and parents, and if they have some understanding of how the world works around them, then they can pass that knowledge on, they can make good choices in their own lives.
One thing I would say is, for professors who've never used a real scientific facility, I would say that does make it a lot more interesting.
Don't try and do everything at once. The first time through is not going to be perfect, so be prepared to change things on the fly or be prepared to make multiple iterations.
The feedback we're getting is that I think the students do like this lab as well as some of the other ones that Ingrid redid, just because it is a little more active.